Now we're going to get into the photoreceptors that actually allow us to see light vision. So take in and interpret the light rays as a vision. There are two types of photoreceptors that take in light information: rods, which are the more common of the two photoreceptors, and then cones, these colorful ones. Rods detect dark vision, so they don't have super sharp vision associated with them. They are what we use for like night vision. They're found in the peripheral regions, and they tend to take in certain light rays and interpret them. Whereas cones are going to take in other lengths of light. There are three types of cones. We have green cones, blue cones, and red cones, I believe. And they help us to visualize all the different colors. The cones are mainly found in the macula lutea, in the region of most visual acuity, the fovea centralis. Both rods and cones contain two proteins. One is called an opsin, the other is called retinol. Retinol is formed from vitamin A. Where do we get our vitamin A? Hopefully you guys are already saying it, but if not, from our carrots, from our orangey vegetables. Vitamin A is a fat-soluble vitamin. We talked about it last semester in Chapter 6 when we were talking about vitamin A overdose, and it causes the oranging of the skin. It doesn't really cause any real problems, but if any of you ever watched Bugs Bunny, he was always eating carrots because he wanted to have good eyesight. There are different types of opsins depending on the size of the wavelength that is being taken in. So rhodopsin is what is used in our rods, and then there are different photoopsins that are used for our cones, but they each take in different light rays. And so here we have, well, I just said this, rhodopsin and then photoopsins. And they take in the light information, and then they can convert it, transduce it into electrical impulses that move to our brain, to the occipital lobes of our brain. And here are the blue, green, and red opsins that I talked about, or cones with their opsins. A disorder associated with our photoreceptors is color blindness. And color blindness is an X-linked recessive disorder. What that means is that it's on the X chromosome. Females have 2 X chromosomes, males have 1 X chromosome, and then they have the Y chromosome. So females can actually have a recessive X chromosome, but still have normal vision because of their normal X chromosome. Males are either going to have normal vision or they're colorblind because they only have 1 X chromosome. So you see this more often in males. And what's typically happening is the cones don't function properly, or there's one cone that is completely absent. The most common color blindness is red-green color blindness, and this is a colorblind test here. This number, if you can see it, what you would see is a 15 if you're normal vision, and if you're colorblind, you'll see a 17. My son, so I have 4 kids, and my youngest, who is going to be 16 this November, is colorblind. And down here, you can actually click on this, and you will get to do your own colorblind test. Most of you probably already know if you're colorblind or if you're not, but it's a fun test. And if you have someone in your life that you're not sure about, you can have them take the test, and it might help you decide or determine if they are colorblind. Adaptation to light doesn't occur immediately. So with smell, we adapt very quickly, but with light, we don't. So when you walk out from a dark area, say you went to a movie during the day, you're in that dark theater, when you walk out into the bright sunlight, you actually get pain in your eyes. You have to shut your eyes. You're maybe covering your eyes, squinting a lot until the pupils constrict, and it's the iris that is causing the constriction of the pupil. Once the pupils constrict and only are allowing a small amount of light to come in, then you can see normally without pain. This can take up to 10 minutes. Usually the pain only lasts for a couple of minutes though. Dark adaptation occurs a little bit faster. So it only takes 1 or 2 minutes before you can start seeing in the dark. But your best vision in the darkness is going to take about 30 minutes. And in this case, when the lights go out, you're laying in bed, getting ready to go to sleep, you shut your light off, and it's pitch black. After a couple of minutes, you might start seeing shapes. If you're like me, you sometimes do things like this and just kind of move your hands in front of your face in the dark because it's so wild that you can't see anything. And then all of a sudden you start seeing your hands moving around. That is because your pupils, which are really, really small, start to dilate. The irises are allowing the pupils to dilate to take in as much light information as possible. The last thing about our vision that we'll talk about is the optic nerve. So we have 2 optic nerves, one for each eyeball. We have a left optic nerve that comes off of the left eye and a right optic nerve that comes off of the right eye. But the information, you've always heard, everything on the left. So yeah, it kind of looks like that. This is my left hand. It's so funny when I look at myself. Okay, everything on the left side of the body moves to the right side. Everything on the right side of the body moves to the left side, right? So the left optic nerve actually does converge with the right optic nerve at this region called the optic chiasm. And some of the information, all of the medial information, crosses over and moves to the right side. The right optic nerve, the medial information moves to the left side. All of the lateral information stays on the same side. So we're getting information from both our right and left eye in both occipital lobes. And this allows us to interpret the information more effectively. If there is damage to any area along the optic nerve, specifically at that optic chiasm, it's going to cause damage to vision, either medial, lateral, or potentially all of our vision. All right, I'm going to stop this one, even though it's short, because we're done with our eyeballs. So I will see you in our next video on hearing and equilibrium.